Hello students, my today's topic is about types of instruction formats from the unit number 3 Central Processing Unit, Computer Organization and Architecture subject. The objective of today's topic is to learn about the type of instruction formats like 3 address instruction, 2 address instruction, 1 address instruction and 0 address instruction. So friends, let's see what computer performs. A computer performs a task on the basis of instructions provided. And what is instruction? An instruction in a computer comprises a group of called fields. This field contains different information. As for computers, everything is in 0 and 1. So each field has different significance on the basis of which a CPU decides what to perform. The most common fields are operation field, which specifies the operation to be performed like addition, subtraction, etc. The second one is a address field, which contains the location of operand like register or memory location. And the third field is a mode field, which specifies how operand is to be founded. That means how to identify at which location the operand is actually stored. Now friends, CPU organization. In CPU organization, an instruction is of various length depending upon the number of addresses it can contain. Generally, CPU organizations are of 3 types on the basis of number of address field. On the basis of number of address fields like single accumulator organization, general register organization and stack organization. Now friends, to understand the different type of instructions, we will consider following example. That is, we will take x is equal to a plus b multiply with c plus d. Now, by using this example, we will understand different kind of instruction formats. Let's see 3 address instruction. So, in this type, it has 3 address fields to specify a register or a memory location. A program created are much more short in size, but number of bits per instruction increases. Yes, because we are using 3 address places into a single instruction. So the size of the program is shortened. These instructions make creation of a program much easier, obviously, but it does not mean that program will run much faster, because now instruction only contains more information, but each micro operation will be performed in one cycle only. See, this is the format in which you can see the first one is a opcode, then destination address, source address and mode of the right. Now let's see the example. Consider that we want to perform addition of two memory locations, that is variable A and variable B, and the answer is going to be stored into Now let's see the example. Here add R1, A, B. So from this instruction you can see that we are going to perform addition of A and B, which are stored in memory, and the answer is going to be stored in R1 register. And the second thing, we are going to perform addition on C and D, and the answer is going to be stored in R2 register. Again, now we want to perform multiplication of the content of R1 and R2 register, and the answer is going to be stored into the memory location of X. Here we can see that R1 and R2 are two processor registers, and M of A, it denotes the operand at memory address which is symbolized by A. So MA denotes the operand at memory address symbolized by A. So from this example we can see that A and B will be added, after that C and D will be added, and then the result of addition of A and B and the result of the addition of C and D will be multiplied. So this is the way how 3 address instruction works. Now let's see another type, that is 2 address instructions. This is a very common in commercial computers. Here 2 addresses can be specified in the instruction. Unlike 1 address instruction, the result in 1 address instruction was stored in accumulator, but here result can be stored at different locations rather than just accumulator. But it requires more number of bits to represent the address. So here we can see the format of the 2 address instruction. First part, it represents the opcode, then destination address, source address, and the mode of operation. Now let's see the example. Here 2 address instructions is using first instruction. We can see that the opcode is move, then destination register, that is R1, and then source address, that is A. That means we are simply moving the value of variable A from memory location to the register R1. Again, now we are going to perform addition, that is we are going to add B into R1. So we will have the answer into R1 itself. R1 plus M of B will do addition of these two, and answer will be stored into R1. Then we will move the value of C from M of C to R2. Then the value of D from the memory location will be added to R2 register, and the answer will again be stored into R2 itself. Then we will perform R1 multiply R2, so that the multiplication will be performed on additions of AB and CD, and then the answer of multiplication will be stored into R1 register. So this is the way how 2 address instruction works. Now see, we want the address into the variable X. So what we are doing? We simply move the answer which is stored into R1 to the memory location symbolized by X. Now let's see another type of instruction, that is 1 address instruction. This type of instructions uses an implied accumulator register for data manipulations. One operand is in accumulator and other is in the register or memory location. The implied mode means that the CPU already knows that one operand is in the accumulator register. So there is no need to specify the another operand. So here we can have the structure of the instruction like opcode, then operand or the address of operand, and mode of operation. So let's see the example. Here it uses the accumulator register for all the data manipulations. That means first of all we will load the value of A into accumulator. Then we will perform addition of accumulator, content of accumulator with the memory location specified by B, and answer will again be stored into accumulator. Then whatever answer we get from the addition of A and B will be transferred to the memory location, temporary memory location, which is symbolized by T, M of T. Then again we will use accumulator and we will load value of C into accumulator. Then again the addition of accumulator, content of accumulator and the content of memory location symbolized by T will be done and the answer will be stored into accumulator. After that, the temporary location which contains the addition of A and B will be multiplied with the accumulator content. The latest content of accumulator is the addition of C and D. So indirectly here we are performing A plus B multiplied by C plus D, and the answer is again going to be stored into accumulator. And at the last we want the answer into the memory location specified by X, so we will simply store the content of accumulator to the M of X. So this is the way how one address instruction works. All the operations are done between the accumulator register and memory operand. So here T is taken as the address of a temporary memory location which is required for storing the intermediate results, right? Now let's see the fourth type, that is zero address instruction. A stack-based computer organization do not use address field into the instructions. To evaluate any expression, first it is converted to the reverse Polish notation, that is postfix notation. And the structure would be like this. We will have a stack and whatever operation we want to perform, that will be performed on the topmost two elements of the stack. So we have to simply push those elements into the stack and then perform the operation. Now let's see the example. So here it is necessary to convert the expression into RPN. So whatever our equation was, x is equal to a plus b into c plus d, for this equation the equivalent RPN equation would be AB plus CD plus star. Now let's see the stack operation. So first of all we have to push the value of A onto the stack, that is top of stack. Then again push the variable B, value of B, to the top of the stack. Then the third thing is addition. So we have to perform add operation on the top of the stack, A and B, two topmost elements A and B, and the result will be stored on the top of the stack. Now again push value C into the stack, again push D into the stack, and then again we have addition. So C and D will be added, that means the two topmost elements C and D will be added and the answer will be stored on the top of the stack. Then whatever topmost elements are now in our stack would be the addition of C and D as well as A and B, right? So we will perform the multiplication, that is our next symbol, into the RPN. So we will perform the multiplication on the two topmost elements of the stack, and again the answer will be stored onto the top of the stack, right? So at the last we want the result into X location, memory location X. So simply perform pop X operation so that the value, the final answer which is stored on the top of the stack, will be transferred to the memory location symbolized by X. Hope students you find the topic interesting. Thank you.